In this video, I want to discuss part-part-whole problems. And these problems involve some kind of static relationships among particular sets and its two disjoint subsets. So join and separate problems have some kind of direct or implied action and a change over time. However, in part-part-whole, we just have two groups that we want to combine into one. Since we're not actually joining one set with the other, both of these subsets have equivalent roles in the problem. So instead of having three different types, we only have two: the part unknown and the whole unknown. Let's start with whole unknown problems. As an example for a whole unknown problem, we have 8 boys and 7 girls were playing soccer. How many children were playing soccer? So we can see that in order to set up the number sentence, we would do 8 plus 7 is equal to what? Just like a join problem with the result unknown. However, with a join problem, we actually have a change taking place over time, and here these are disjoint static sets. We're not actually changing anything. The most common type of direct modeling strategy would be joining all, having a group of 8 and a group of 7, and then combining them. The common type of counting strategy would be counting on, in this case starting with 8, counting up 7 more, and getting 15. Next, let's look at part unknown problems. 15 children were playing soccer, 8 were boys and the rest were girls. How many girls were playing soccer? So in this case, we have two parts, the boys and the girls, and then the whole would be all of the children. We know the whole piece, and one of the parts, but not the other. So this would be an example of a parts unknown problem. And there's no commonly used strategies corresponding to part unknown problems for either direct modeling or counting.